Hi everyone, this is Mr. Richmond, and for this video I'm going to walk you through how to count for subatomic particles using the periodic table. So I'm pulling these notes directly from your PowerPoint slides, and before we get into some of the calculations, let's talk about those three subatomic particles that we discussed in class. They are protons, neutrons, and electrons. We know that protons and neutrons can be found inside the nucleus. They also make for over 99% of the atom's mass. And an important concept I want you to understand is that one proton and one neutron each equal a total mass of 1 AMU, or atomic mass unit. We're dealing with something that's extremely small, so grams wouldn't make sense. It'd be 0.0000 however many grams, so we can't really use a unit of measurement for mass. We got to use atomic mass unit for us to be able to get an accurate depiction of the mass of a proton and a neutron. So again, one proton is the equivalent of 1 AMU. One neutron is also the equivalent of 1 AMU. Protons have a positive charge, and the number of protons gives the identity of the element for our periodic table, and that might make it a little bit more sense when we go over some examples. Neutrons do not have a charge, they're neutral, and they also have the same mass as I mentioned earlier. They have the same mass as a proton of 1 AMU. To get the total mass number, we want to add up the sum of protons plus neutrons to get our mass number. Electrons we don't really even consider to have much mass. They do have some, but when we are calculating for the total mass, we don't even consider electrons to be a part of this equation. They are negative charged. They're not inside the nucleus. They're held together by the opposite attraction between the positively charged protons and the negatively charged electrons, and they're held together in some different energy clouds. We're going to talk about Schrodinger's theory of the atomic model in class. So those are the three subatomic particles that I want you to understand. Now let's go ahead and count some of these protons, neutrons, and electrons. So we call this top number here the atomic number, and this tells us two things, at least if we have a neutral atom, meaning that's not an ion, and we'll talk about what ions are at a later date. But this atomic number tells us both protons and electrons. I have just as many positive charges as I do negative charges. They're going to cancel each other out. So my atomic number tells me both protons and electrons in a neutral atom, which I'm assuming anything on the periodic table is neutral at this point. Neutrons is a little bit more difficult. Remember, the total mass number is protons plus neutrons. We're going to talk about isotopes again at a later date, but for right now you need to understand that in order for us to calculate the amount of neutrons, you want to round the mass number to the nearest whole number, which in this case would be 1. You want to then subtract the atomic number, so 1 minus 1 is going to give us 0 neutrons for hydrogen. So hydrogen has a total amount of 1 proton, 1 electron, and 0 neutrons. Let's go ahead and try fluorine. Again, the atomic number, this top number, is going to tell me how many protons I have as well as electrons. However many positive charges, I have just as many negatives to cancel it out. It's a neutral atom. And then neutrons, again, you want to round your mass number to the nearest whole number, which would be 19, minus my atomic number 9, so that's going to give me a total of 10 neutrons. And then let's do one more. Let's do scandium, atomic number 21. So again, this is a neutral atom. I'm assuming that there's 21 positive charges, there's 21 protons. To cancel it out, I have 21 negative charges, 21 electrons. Finding the amount of neutrons, I'm going to round my total mass number to the highest, or the nearest whole number, which would be 45. 45 minus my atomic number of 21, I believe that's going to give me 24 neutrons. So good luck counting your subatomic particles. I hope this video helped, and